Okay, we're going to finish up our conversation with the graphs of tangent and cotangent by illustrating graphing the different transformations. Well, as we saw earlier, in order to graph tangent and cotangent, we need 5 distinct locations, 2 asymptotes, and 3 equidistant points. So on the graph that you'll be provided, you will have to determine values to place on all 8 of these dotted lines. So we'll start with these 2 vertical lines. This is where we will determine the new left and right bound. Well, depending upon which trig function you use will help dictate how you find it. So if we're using tangent, we saw earlier that the original left bound was at negative pi over 2 and the original right bound was at pi over 2. Well, if it was cotangent, the left bound was at 0 pi and the right bound was at pi. So these are critical bits of information in helping us determine where the 2 asymptotes will be located. So if we took the general form of tangent and focus in on just the portion that we're going to use, which is the bx minus c, the portion inside the parentheses. We saw when we did sine and cosine, we had a generic format. The generic format was left bound less than whatever was inside the parentheses less than right bound. Well, we established that for tangent, the left bound was negative pi over 2, right bound pi over 2. So this will be the format we will use to help us determine the new left and right asymptotes for tangent. Well, when we look at cotangent, the general form is the same. We'll still use what's inside the parentheses. And so our inequality will be the exact same inequality, at least the format is. The only difference is the actual numbers that will be applied for the left and right bound. Cotangent has 0 pi and pi. So just like when we did sine and cosine, once we found these 2 left and right bound boundaries, to find the other 3 values to be placed on the vertical dotted lines, we would average those 2 values we just found. Then to find this next vertical line, we would average the 2 last values, and then we would average again. And so now, let's apply this in a real problem. So, there's the graph that we'll be using. And so we will be placing a value on all 8 of these dotted lines. Well, let's start with the easy stuff. It's in the general form. So our A here is 3, and we'll jump to the D as 1. Just like when we did sine and cosine, we first focused in on these horizontal lines. They're a little bit more straightforward. The D, as we saw in sine and cosine, was the midline. So we can place 1 on our middle horizontal line. The line above, in sine and cosine, it was the maximum. But tangent and cotangent don't have maximum and minimum. But the way we find that value will still be the same. We'll take whatever the midline was and add the distance of the A. In this case, 1 plus 3 puts us at 4. So from the midline, we went up 3. And so from the midline, we're also going to go down 3. Puts us at negative 2. Now it's time to focus in on the vertical lines. So our left bound and right bound. We established earlier that because it's tangent, we have to consider what would be the original left and right bound. We saw for tangent, left bound negative pi over 2, right bound pi over 2. So now when we set up our inequality, we're going to again focus in on what's inside the parentheses. So when we set it up, all we're now going to do is just solve for theta. We'll add pi over 4 on all 3 sides, leaving us with theta over 3. Multiply 3 on all 3 sides, and then simplify. So now we have the new left bound, which is negative 3 pi over 4, and the new right bound at 9 pi over 4. So that's where our new vertical asymptotes will be located. And so now to find the values for those three remaining vertical lines, we're just going to average, average, average. So the average of our first two values we have is actually 3 pi over 4. Now we're going to average the 3 pi over 4 and the negative 3 pi over 4. The average of those two is 0 pi. And now to find this average, again, we're taking the middle, 3 pi over 4, averaging it with the 9 pi over 4. That gives us 3 pi over 2. So now we have all the values for our various dotted lines. Now we can determine the two asymptotes and the three equidistant points. Well, the first asymptote is located at x equals negative 3 pi over 4. Notice I use an entire equation to identify the asymptote because it is still a vertical line, so therefore I should use an equation. Sometimes you'll see x's not equal to negative 3 pi over 4 because of it being a dotted line. But what's critical is that you write it in some form of an equation or inequality. Second vertical asymptote is located at x equals 9 pi over 4. And now for our three equidistant points. Because we're working with tangent, tangent was right up. And the fact that the A is the positive, which means we does not reflect. So it will continue to be right side up. So I can plot those 3 points, showing that the right side is up. So all I need to do now is just identify those coordinates. So the coordinates for this first point, as you can see, the abscissa or the x coordinate, 0 pi, connects with the y coordinate, negative 2. The next point connects with the 3 pi over 4 and the 1. And the last point connects with the 3 pi over 2 and the 4. So now we have all three of the equidistant points. And all we can do is just graph it. So there we go. Got a couple more examples. Cotangent. Again, we're going to put values on all 8 lines. We know A is 4 and my D is 3. Because D is 3, that's my midline. So let's put the 3. To find the dotted line above, it's the D plus the absolute value of A, which in this case, 3 plus 4 puts us at 7. The one right below, we subtract the D minus the absolute value of A. 3 minus the 4 puts us at negative 1. Now let's work with our two boundaries. The left bound for cotangent, because it's cotangent, the left bound is at 0 pi, and the right bound is at pi. So when we set up our three-sided inequality and substitute all the values, bx minus c in this case is that 2 theta plus 11 pi over 6. Substituting everything, now it's time to solve for theta. Let's subtract that 11 pi over 6 on all three sides and then divide everything by 2. So now we have our new values. Our left bound will now be 11 pi over 12, and our right bound will now be negative 5 pi over 12. Now to find our other three, simply average those two values. That gives us negative 2 pi over 3. Average those two values. That gives us negative 19 pi over 24. And average those last two to give us negative 13 pi over 24. So now we're ready to give the two asymptotes and the three equidistant points. My two asymptotes, my first one is located at x equals negative 11 pi over 12, and the second one at x equals negative 5 pi over 12. Three equidistant points, because it's cotangent. Cotangent is not right up. Tangent is the one that's right up. And the fact that A is still positive, it does not reflect. So everything stays just as it is. No right side up. So I can plot those points. Now that I got the points, we can follow with the coordinates. This first point connects the negative 19 pi over 24 with the 7. Next point connects the negative 2 pi over 3 with the 3, and the last point, negative 13 pi over 24 with the negative 1. So let's go ahead and draw it. We've got, there's our graph. All right, 2 more examples. Set up in the general form, so our a is negative 5 this time, while our d is 4. So therefore, 4 is the midline. From here, we're going to take our d and add the absolute value. So that says 4 plus 5. So from the 4, we're simply going up 5 units. And from the 4, we're going down 5 units. So 4 minus 5. Now let's work with our left and right bounds. Because we're working with tangent, left bound is negative pi over 2, right bound is positive pi over 2. When we set up our inequality, we'll have our specific left and right bounds, and we'll use whatever's inside the parentheses. Let's solve for theta. Subtract pi over 4 on all 3 sides, leaving us with the theta over 3. Multiply 3 on all 3 sides, gives us our new left and right bound. So the new left bound, negative 9 pi over 4. New right bound, 3 pi over 4. Well, time to average. When we average those 2 values, negative 3 pi over 4. Average again, negative 3 pi over 2. And average one last time puts us at 0 pi. So let's go determine those 2 asymptotes and the 3 equidistant points. First asymptote, x equals negative 9 pi over 4. Second one, x equals 3 pi over 4. The equidistant points, well, we're working with tangent. Tangent. Tangent, normally right up. But because the a is negative, the entire graph will reflect. So instead of being right up, it's actually the left side up. So I can plot those points. This is critical to acknowledge the trig function and the sign of your coefficient. So let's plot these points and determine the coordinates. They intersect with the negative 3 pi over 2 and the 9, the negative 3 pi over 4 and the 4, and the 0 pi and the negative 1. There's our 3 coordinates. So now we can graph it. Okay, one last one. General form. Again, the a in this case, negative 3. The d, negative 7. So therefore, our midline is at negative 7. From the negative 7, we're going to go up. And again, we're adding the absolute value. So we're not going up negative 3. We're going up 3. Puts us at negative 4. And again, we're going down 3. From that negative 7 puts us at negative 10. So let's work with the left and right bounds now. Because it's cotangent, the left bound for cotangent, 0 pi. Right bound, pi. So when we set up our 3-sided inequality, we'll put in our left and right bounds and consider what's inside the parentheses. That's our 4 theta plus 5 pi over 3. Substitute everything into the inequality and let's start solving for theta. We'll subtract our 5 pi over 3 and then divide by 4. There's our new left and right bounds. So the left bound is now negative 5 pi over 12 and the right bound negative pi over 6. So let's average. We'll average again and average one last time. So let's go set up the 2 asymptotes and the 3 equidistant points. First asymptote, x equals negative 5 pi over 12, and the second one, x equals negative pi over 6. Because we're working with cotangent and a negative, cotangent is not right up. But because the a is negative, it will reflect. So it will be right up. So there's our 3 points. So the coordinates, negative 17 pi 48 with the negative 10, the negative 7 pi with the 24 with the negative 7, and the negative 11 pi over 48 with the negative 4. We can graph it, and there's our final graph. So hopefully this helps as you begin to do your practice.